AI. The question that you see most often, even when you sit down with clients, is, but how do I know that what I'm receiving, the output is going to be predictable and consistent? And I think that's where this element of explainability comes in, right? So how do you approach that sort of question with a client, at least in the initial stages?
Okay, yes, there's one thing I'm always repeating because it's also very funny when I have interviews or panels. So sometimes they ask you to give you examples from the past, and you give like good examples. And the first question that everybody is eager to ask is, which model did you implement? You know about it? It's the least important thing, because when you implement a solution, the most important things are what is the input, what is the goal, and which metrics you are going to use to assess the goal. The model doesn't matter. Why? Because you can have different approaches, and even whatever you're implementing right now can be obsolete in 5 years. So who cares? But the problem is still there. So for instance, you want to find talent in sport, that's still a problem, probably will be a problem in 50 years.
Yeah. But so we go back. I like your sport analogy. But we go back to the same problem. I think we're still not at the center of the question. So our industry specialist is the coach, and he tells us, well, me, I know, I have the experience, I can see, I have the expert's eye to see the talent. And you're like, well, no, because we can identify markers, and we have like a baseline, and with those different KPIs and indicators, those markers, we can have a sort of a weighted average or a way to measure those markers and come to something. So do you think that explaining the process and how you use those markers to get to a sort of data measured and data driven solution is the way to go about it, instead of saying, let me do it, we have AI and we can solve that for you? That's what you're saying, right? To really explain that it's not AI or anything, it's like, we measure those markers, we analyze all the data around each marker, then we have a formula that gives that some ponderation of anything mathematically, and then through enough data, aka in that case, filming the players to see when they tick the box in those markers, we can come to a result. Is that what you're saying?
Okay, yes. So in order to understand how it works, it must be clear how a machine learning project gets to an optimum solution. So the point is, it's counterintuitive for a person because it goes backwards. So the most important thing, as I mentioned in the beginning, is to understand the goal and how to measure the quality of your goal, right? Which is counterintuitive because in the beginning, a human will start thinking about the algorithm. Basically, the way machine learning works is like, forget about the algorithm, the machine will solve it. But what you need to be very clear is what you want to achieve. Okay, but this creates an issue for explainability. And by the way, there is also another interesting question, which is the difference between interpretability and explainability. But we will get to that. Okay. The point is, okay, you describe the goal, right? And then the machine learns the most optimal way and can generalize like a good solution for that. Right? But the question is, at some point you might say, okay, how did you get there? It's like, imagine, it's like if you have a person and this person solved the problem in a snap, and you say like, oh yeah, you're brilliant, but can I have some control over it? For two reasons. Number one is governance. There are issues related to the way that you are assembling a solution that must be governed by ethical principles, or something related to constraints that we want to apply. Okay, it's not even ethical. Sometimes it's just constraint, for instance. It's whatever we evaluate as important, valuable. So the solution that is proposed by the algorithm must be mitigated by the constraints that we have. Okay, I can give you a stupid example from real world. Okay,
please.
Okay, and I can give you some interesting examples from the industry. So there is a very famous computer vision problem that was created years ago, and it's exemplary on what happens when it goes off the rails and you don't understand what it's doing. So they had to classify fish, right? So to recognize fish in pictures for biological purposes, they need to assemble, like, if I remember correctly, they need to assemble a data set on whatever. So they assembled pictures of fish, different fishes, different shape, different kind of fishes. And with, they collected, I don't know, like some thousands images. And then they trained the model. And the model was capable of recognizing fishes in the test set. But it failed because at some point it was recognizing fish in an image where there was no fish at all. All right. So in this case, you start analyzing, it's like, okay, what makes the prediction wrong? What's wrong with that? And they found that in these images, there were persons, right? So they said, what's going on in here? And what they did is that after a while, they realized that the model was trained on, so most of the images of fish is people that was going fishing, and they were holding the fish with their hands. And the model learned somehow that a very good indication of a fish is to have fingers, basically, on the bottom. So at some point, basically, the model was looking for fingers in the images. So the point is, you kind of not defined very well. So in this case, explainability was applied, and we managed to understand that the model made some false assumptions because we were not correct in the way we assembled the training set.
Yeah.
But I can give also some other examples that are even more interesting or for an ethical purpose.